Okay, section 3.4 in our chapter on graphing is about the concept called slope. Does anything come to mind when you hear the word slope? Pardon? Okay, a hill. All right. A mountain, an incline, a slant. Sometimes people think of skiing when they think of the word slope. I'm not a skier myself. I tried the experience once. It didn't work real well for me. So I'll just teach about slopes. I won't actually go do it again. All right, so the slope can sometimes be called the slant of a line. Okay, it's the slant of a line. Now I'm going to give you quite a few definitions for slope, and then we'll see which ones we actually need to use. All right, for some reason, for the word slope, the mathematicians chose to use letter M. It is really unknown as to why they chose to use letter M. If you read about it, you would find that a lot of the work done on the concept of slope was done by French mathematicians. And there is a word in French, I don't speak French, but there is a word that has to do with mountain, which also starts with an M. So maybe that's where it came from. Who knows? All right. The slope of a line, letter M, is sometimes called the rise over the run. It is how much do you rise compared to how much do you run, and that would give you the slant of the line. So it's how much you have to go up compared to how much you have to go over. Well, a rise, in the sense of graphing, is a vertical change compared to the run is the horizontal change. In mathematics, in our graphing that we study, vertical is controlled by the y's. Horizontal is controlled by the x's. So it is sometimes called the change in the y's compared to the change in the x's. Now you want to be careful. With an ordered pair, with a point, it is always in the order x, comma, y. And we think about the fact that x has to come first in an ordered pair. In slope, the numerator is the y and the denominator is the x. So the y over the x. Okay, let's continue with this way of defining slope. I'm going to use a triangle y over triangle x. The triangle is really the capital letter delta. It is capital delta in the Greek letters. You've probably seen some fraternity or sorority shirt or something that might have a delta on it. But in mathematics, we use delta to mean change in. Change in. Change in is written as delta. Finally, here comes the formal formula for slope. It is y1 minus y2 over x1 minus x2. I will mention to you that in my math lab, in the textbook, in so many settings, you will see the formula written a little differently. You will see it as y2 minus y1 over x2 minus x1. These both work. But my version is the top one. The reason I like it is that I just have this sense that 1 ought to come before 2. It doesn't make any difference. Now, what are those x1s and y1s and x2s? What is all that? And I will show you. That has to do with if you know 2 points on a line. If you know 2 points on a line. Now, what are we going to call 2 points on a line? We're going to call them point number 1, which is x1, comma, y1. That would be point 1. And x2, comma, y2, which is point number 2. So when I talk about these letters in the formula, it has to do with the x and the y from 2 different points. We'll do plenty of examples with that in a few minutes. All right, let's go ahead, and I'm going to probably come back to this. So if you are taking, well, I tell you what, I'm going to go ahead and do it now, even though it's going to be a little bit out there because we're not doing any problems yet. All right, slope of a line. One thing we're going to do is look at a picture of a line and figure out the slope. We're just going to count the rise, we're going to count the run, we're going to write it as a fraction. That's one thing we're going to do. Another thing we're going to do is use the formula if somebody says, hey, here are the coordinates of 2 points on a line, let's find the slope. And we're literally going to grab the numbers, put them in there, and crank out the fraction. Finally, we're going to find the slope from the equation of a line. If you have a line, let's suppose we have y is equal to 5x plus 2. This form of the equation of a line, when it is in solve for y equals, and we did some practice, we had some exercises where we had to solve the equation for y. Now we're about to find out, why did we practice that so much? When you solve an equation, a linear equation, when you solve it for y, then this number and this number represent certain characteristics of the line. And they represent very important characteristics of the line. The form that we're looking at is y equals mx plus b. The 5 is the slope of the line. The 2, and we talked about this last week, is the y-intercept. So if you solve an equation for y equals, and you take a look at the coefficient of x, in this case 5, that's the slope of the line. The constant number is called the y-intercept, and you know what that is. It's where the line crosses the y-axis. So we will use the equation of the line to find the slope. So we're going to do it 3 ways. The first way, we're going to find the slope of a line by simply looking at the rise compared to the run between 2 points on the line. Then we're going to figure out the slope of a line if I know the coordinates of 2 points, and I will plug in appropriately. I'll give you examples of that, don't worry. Then, finally, we're going to find the slope of the line from the equation, and it's the easiest thing. Once you get it in the form y equals, the slope of the line is this number right here, the coefficient of x. Okay, so let's take a look at the first few problems in my math lab. Now I will probably go down to the bottom of this page because you can't read that minuscule little print in class. If you were watching the video, you could probably see it. But Question number 1 says, and then I'll go to a space where I can see, find the slope of the line that goes through the given points. Okay, I'm given 2 points. If I go down, find some workspace, you are given that the line goes through 9, 7, and 8, 9. And I want to know the slope. Okay, here is my process. When you're given 2 points, one of them is x1, y1, and one of them is x2, y2. Point 1, point 2. The slope. The formula that I use, and please keep in mind, if you say on MathLab, show me an example, give me some help, they're going to write the formula a little backwards. Well, actually, they would say I'm writing it backwards, but we would differ. It is y1 minus y2 over x1 minus x2. In the slope formula, y's on top, x is on bottom. So I'm always going to look at my original problem and mark it. Y's on top, x is on bottom. That is just a visual thing. That is just to help your eyes connect to the numbers we need to. Okay, the y's. The way I'm going to write it is simply 7 minus 9 over x is on bottom, 9 minus 8. If you were looking at this in my MathLab, they would have had these two exchanged, and you would have done 9 minus 7 over 8 minus 9. And I always just think it feels weird to be going backwards, so I don't, because it doesn't matter. All right, the numerator simplifies. 7 minus 9 is negative 2. The denominator simplifies as 1. If you get a fraction that is equal to a whole value, an integer, then write it as an integer. If it's not, leave it as a fraction. Never write a slope as a mixed number. Here the slope is negative 2. Now that doesn't mean a whole lot to us yet, but it will. For right now, it's kind of mechanical.
You said never write a slope as
a mixed number. An improper fraction will be fine. Never 2 3/4. Never write it as a mixed number. Okay? So question number 1, can you figure out the slope of a line if I give you 2 points? Okay? Let's look at number 2. Back up. Find the slope of the line that goes through the given points. So this one is a repeat of that process. And you are given -1, -10, and -3, -5. So I think about the slope formula, which the way I write it is y1 minus y2 over x1 minus x2. Y's are on top, x's are on bottom. So that gives me, the slope is -10, that's my y1, minus -5 over -1 minus -3. So the minus sign is part of the formula, and these quantities both happen to be negative. So you want to be careful with your signs now. What do I do when I have minus and negative? You end up adding. So you would say, change both of those to pluses. I have -7, I can get it in a minute, -10 plus 5. So what do? I subtract and keep the sign of the big one, -5. The denominator, I have minus minus again, so that becomes plus. I have -1 plus 3, which is 2. Does it divide evenly?
No.
No? Done. You would reduce if you could. If you got 10 over 4, you would reduce it to 5 over 2. So it's always reduced, but left improper if necessary. Now this time we got a negative slope. Don't know what that means as it applies to lines, but I'm about to show you. All right? Let's look at number 3. Now number 3, I'm going to stay up here on the picture. I'm going to need it. All right, in class I've blown up the picture just about as large as I can. The question's not showing, so I'll read the question. It says, find the slope of the line if it exists. Makes you wonder, could it not exist? We will talk about that. All right, on your picture, you're finding the slope of the line. The author of this has been very helpful because she has given you a point here and a point here that are highlighted. And it's in your best interest to use those 2 points. Now, you can start at whichever one you please. I like to start at the bottom point. Okay, but I'll show you that you don't have to. If I start at the bottom point, what vertical change do I have to make to get to the height of the second point? I have to go up 1, 2, 3, 4, 5. I have to go up 5. To get to that other point, the run, remember rise over run? The run is 1, 2, 3. I went 3 to the left. Do you agree that I have written up there the rise and the run? Okay, so slope is rise over run. The rise is 5. And would you consider up to be a positive or a negative direction? Positive. The run is 3 to the left. Would you consider that positive or negative? To the left should be negative. So there is my slope.
So anytime you go left, it's always going to be a negative.
Yes. What other direction would be negative? Down. So up is positive, right is positive, just like the axes. But left is negative, down is negative, just like the axes. Okay? Now, what if, this is just a what if you went the other direction? What if instead you had started at this point? Because there's no rule that says where you have to start. So if you started here, what would be your vertical change? Yes, it would be down 5. But then what would your horizontal change be? To the right, positive 3. Which means if you did it that way, your slope would be negative 5 over 3. Are these two equivalent? If you have a positive divided by a negative, is that the same as a negative divided by a positive? Yes, they're both negative quantities. They are equal. Math lab should take either one of them, and so will I. Okay? So just because I like to start at the bottom point and move toward the top point doesn't mean that everybody likes to do that. But you do need to do the rise over run to get from one point to the other. Okay, let's do another one. Find the slope of the line if it exists. All right, once again, I'm going to start at the bottom and I'm going to move toward the top. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 units up. That's my rise. Then the run is 1, 2, 3, 4, 5 units to the left. If you could see that blob. So the slope is the rise over the run. What was my rise? 9. What was my run? -5, because it went to the left. And if you went the other way, you'd get -9 over +5. It doesn't matter. Anybody have a question about seeing slope from a graph? All right. I want to pause for a minute, not pause in the video, but just take a step. Instead of going to 5 through 9 just now, I want to write some summary statements. This will be very helpful to you. Yes, so please do copy these down. These will not be test questions, but this is information that will help you answer a lot of questions. This is my classification, there are really only 4 different kinds of lines that you're going to run into. So I'm going to draw 4 coordinate planes. And in each one of those, I'm going to draw one of the kinds of lines. One kind of line is a rising line. And I call it rising because I look at it from left to right. I read from left to right. I do virtually everything from left to right. The other one I'm going to call a falling line. What other 2 kinds of lines could there be? Pardon? Okay, and what would it look like? Straight up and down. Okay, so I'm putting that in the last one. That one's vertical. And what one kind of line are we missing? Horizontal. I always get a little bit amused when I say something about what kind of line is that, and the common answer is straight. Well, I don't think there are any lines that aren't straight, at least not in Euclidean geometry, which is what we study. I guess in some weird other dimension, maybe there are curvy lines, but for us, the definition of a line is going to make it straight. So when I say what kind of line is it, you could say it's rising, it's falling, it's horizontal, or it's vertical. Okay, those are classifications. Now, the slopes. You don't necessarily have to draw these things I'm about to draw, but write down the conclusion. If I picked 2 points on this line, and I did the rise over the run, if I did the rise, it would be up. And if I did the run, it would be right. What signs do those directions have? Up is
Positive.
and right is positive. So the slope of a rising line is always going to be a positive over a positive. I guess it could be a negative over a negative, but the slope is positive. And that is the conclusion that I want you to know about rising lines. If a line rises, its slope is positive. All right, let's look at a falling line. Well, to do the vertical change, it's up. To do the horizontal change, it's a positive and a negative. The slope is a positive over a negative. Now, yes, those could be negative over positive. That'd be the same. But either way, if you have one that's positive and one that's negative, what are you going to get? M is negative. A falling line, the slope is negative, whereas a rising line, the slope was positive. And that is a nice thing to remember. Now let's look at those other 2 special cases. Horizontal. if I pick 2 points on a horizontal line, how much do I have to rise to get from one to the other? None. The rise is 0. And the run, I don't know. It might be positive, it might be negative, because I don't know which way you're going to move, but it's going to be a number, some kind of number. What is 0 over a number? Rise over run. It is 0. M equals 0 is the conclusion. A horizontal line has a slope of 0. Think about it. You're going skiing. This is the surface. You're going to have 0 fun. Okay? And one other way to help you remember that is for me to share my embarrassing skiing experience. I did go skiing once. I was not married to my husband, but I was with his family. His family is a family of athletes. They are very athletic and very competitive too, and not me so much. Okay, so they're all going to go off and ski, so I take a lesson. Okay, this was me the whole day. I couldn't keep my feet on the ground. There was not enough friction for me to stay upright, so I was on my backside all day long. It was horrible. Nobody should pay to have to feel like that.
So you're a 0.
I was a 0, and I was reminded of that, not by my future husband, but in a kidding way by a brother-in-law, that I was a 0. So 0, me on the ground. Okay? Now, vertical. Vertical. If I am here and I am moving up here, then my rise would be, in that case, it would be positive. Agreed? But what would the run be? How much do you run? You wouldn't. It would be 0. The run would be 0 in this case. So you end up with some kind of, the rise actually could be positive or negative, because you might move from the top to the bottom. It's going to be a number. But you get, for the slope, a number over 0. What happens when you try to divide by 0? You don't get 0, you get undefined. You get an error message with your calculator. It is undefined. So M is undefined. Thinking about skiing, can you ski, even good skiers, can you ski on a vertical surface? No, gravity will make you fall off. And if you're not careful, you will end up looking like me. Okay, so to keep these two straight, so you don't get them confused, horizontal, this is me skiing, the big 0. This one, can't do it. Impossible, undefined. Okay, so it would be very nice for you to remember these things. One other thing that I'm going to add to this in these last categories, and I'm going to see if you happen to remember something from a week ago when you worked on this probably. This is a horizontal line. It is cutting through the y-axis at a particular number. Do you remember what the equation of a horizontal line looks like? It isn't the equation is y equals a number. Y equals 5 cuts through the y-axis at 5. Y equals -2 cuts through the y-axis at -2. A vertical line cuts through the x-axis. Its equation is x equals a number. You might wonder or be thinking, well, how about these two cases? You haven't talked about what their equation would look like. Equation is y equals mx plus b. That funny form that we haven't used yet, but I've talked about it. Okay, so we have lots of information there.
Lots of steps.
But it's not going to be that bad. We're going to go through it, we're going to use it, and I can come back to this drawing if I want to. What there are lots of relationships that I want you to remember. I want you to remember that a vertical line has an undefined slope, and its equation is x equals a number. I want you to tie those facts together in your head. I want you to know that a horizontal line has a 0 slope, and its equation is y equals a number. And the other cases of slanted lines, rising is positive, falling is negative, and they are both y equals mx plus b. Okay, so it's a lot of facts right now. Hopefully it will get better as we use it. Let's go to problems 5 through 9 in MATLAB. All right, this is problem number 5, and I'm going to have to blow it up to the point where you can't see anything but the graph. Okay, it has, if you can see the colors, it has a line in blue. Whoops, let me see if I can. It has that line in blue, and it has this, whoa, it has this line in purple. And the question says, for the graph, determine which line has the greater slope. Now, do you agree that they both have positive slopes?
Yes.
Because they are both rising. Is one of them steeper than the other?
Yes.
Which one is steeper?
One.
One has the greater slope. And you can't see what I just did here in class. It is a multiple choice question. Which one has the greater slope? And it was line 1. And I'm going to write because it is steeper. Okay. Problem number 6. I'm going to just get the graph to show in class. The question says, find the slope of this line. Okay, so now we're about to start connecting things. Visually, we see a vertical line. What do we know about the slope of a vertical line? Undefined. So it is undefined. If we were to look at the way we write the answer to this, it says, let me scoot up. It's actually right here. It says the slope is, type an integer or simplified fraction, type n if the slope is undefined. So for this particular question, we would have typed in letter n. You don't type in vertical and you don't write the word undefined, you just do an n. All right, now this is problem number 7. Oh, you can't see that either. Number 7, find the slope of the line x equals 6. Okay, x equals 6. This is where you're going to tie those ideas together that I mentioned. All right, x equals 6. What does it look like if I ask you to graph it? X equals 6. You're going to cut through which axis? The x. So if I cut through at 6, 1, 2, 3, 4, 5, 6. I cut through at 6. I draw that picture. It didn't ask me to draw that picture. I did that either in my mind or on my paper, because now what's the slope of that line? Undefined. So that's why I want you to take the equation, x equals a number, think about what it looks like, maybe draw it, and then say what kind of slope does that have. That is undefined, and it will ask you to type in a capital M. Is that okay? Tying those ideas together. Number 8, this is 8. Find the slope of the line, x equals -2. Which axis will it intersect, cut through? The x, and it will cut through it at -2. So it will look like that. And its slope is undefined again. Kind of expected the other kind, but it's not what they gave us. Is that okay? All right, are we ready to move on? All right, let me shrink this a little so we can have some sense of what's going on. Problem number 10. I will have to go down to my blank paper to do this, but I want us to read it. It says, find the slope of the following line. And it gives us the equation of a line. The slope is. Do you remember how we find the slope of a line if we just have its equation? We haven't done this before. We get y by itself. Okay. So this is number 10. Find. Did we skip 9?
Yes.
Oh, we sure did. I'm sorry. Back up. Oh, there it is. And we need it. It will be good. Number 9. Find the slope of this line. Y equals -4x plus 7. We need number 9 before we do number 10. So I'm glad y'all caught me on that one. This is, do you agree, a slanted line? We just looked at vertical lines and we know about horizontal lines. How do I know this is a slanted line? It has y by itself, and it is in the form y equals mx plus b. That's going to be a formula that you will get very used to using. You'll use it in here, you'll use it in intermediate algebra, and you'll use it in whatever college level math class you end up taking. Y equals mx plus b. The slope of the line is right here. And you don't have to do any work in this problem to answer this question. The slope of this line is -4. It is the coefficient of x. Now I'm going to ask you a question that Math Lab isn't asking you. Is this a falling or a rising line?
Negative.
A negative line, a negative slope, so it is a falling line. That's not part of the question. The slope of the line, when the line is written in the y equals something times x plus or minus another number, the slope is simply the coefficient of x. What that tells you about the line is, if you were sitting on the line, and where might you be sitting on the line? I'm giving you a little preview into a future lesson. Is it possible that you are sitting at 7 on the y-axis? Where did I come up with that? Do you remember from our notes? M is the slope, and B is the y-intercept, where the line crosses the y-axis. So if I were sitting, excuse me, at 1, 2, 3, 4, 5, 6, 7, if I were sitting at that y-intercept, what's the slope? -4. Well, slope is a ratio. It's the rise over the run. Well, I need a denominator. I need a run. What's the denominator when they don't write 1? A 1. From the point, could I do the rise, which says, -4, down 1, 2, 3, 4, and the run, which says 1 positive. There's my line. Y equals mx plus b, and don't worry, we're going to do more with this. I'm just giving you a little preview. It is a powerful formula. When you have the equation of a line and it says y equals, then the coefficient of x is the slope of the line, the rise over the run. If it doesn't have a denominator, you put a 1 down there. The constant number is the y-intercept. It's where the line hits the y-axis. That's going to be super important in a future lesson. And I'm just mentioning it. Your brain might be just going, oh, there's too many things floating around up there right now. But it'll land, it'll take root, you'll be able to use it. All right, so thank you for pointing out that I left out 9 because we're going to need it for 10. Number 10 asks us to find the slope of the line, and the line is, find the slope of 6x minus 7y equals 42. Okay, I can get the slope of a line from the equation if the equation is solved for what? Y. If it says y equals. Okay, to find slope, solve for y equals. So that's what I need to do. I have 6x minus 7y is equal to 42. All right, I want y by itself. So what's the first thing I'm going to need to do? Get rid of that 6x. I'm going to subtract 6x, subtract 6x. I'm sorry, those of you in class, you'd like to see what I'm doing. Better. All right, we subtracted 6x. We're left with negative 7y on the left. We talked about this in a previous lesson. We're going to write the negative 6x first because we want our x first, and a positive 42 at the end. Have I solved it for y yet? No. I need to, I need to divide by negative 7. That gives me y equals, this number is going to be the coefficient of x. It's negative over negative. What do we usually do when we have negative over negative? Make it positive. So I'm going to call it 6/7 x. What is 42 divided by negative 7? Negative 6. This equation is now in the form y equals mx plus b. So if I ask you the question, what is the slope? How will you answer? Yes, slope is 6/7. And that's all the question asks. What is the slope? Now, I'm going to mention something else. That means that if you could find a point on the line, to find another point, your rise would be 6 and your run would be 7. So you'd start at a point and you would go up 6 and write 7, and you would get another point on the line and you could draw it then.
Would it matter where on that line you started?
It wouldn't matter as long as you were indeed on the line. And where we are going to start is always going to be with the y-intercept, because we're always going to know it. If we know m, we're going to know b. which is the y-intercept. But that's in the next lesson. That's in the next lesson. All right, let's look at 11. It says to find the slope. And it gives us negative 5x minus 9y is equal to plain old 4. I'm sorry. What do I have to do to find the slope? What form does the equation have to be in? Y equals. So I'm going to add 5x. That gives me negative 9y is equal to 5x plus 4. And my last step, divide by negative 9. That divides out, and I get y is equal to, I'm just going to leave it, 5 over negative 9x, and I'm going to write this as minus 4/9. I could put plus and just leave it like it is, 4 over negative 9. That would be fine, or I could say that that makes it a subtraction. Question. This is in the form y equals mx plus b. What's the slope? It is, slope is, and I don't like green. Stop that. M is equal to, and it has to have a negative sign somewhere. So it could be like that, or it could be like that, because that is equivalent. It could even be negative out in front, 5/9. I actually prefer one of these because I like the sign attached to either the rise or the run, not just sitting out in front where you don't know what to do with it. Whoops. Is that okay? Yes, ma'am.
Another question on the 5/9 and 4/9, we don't solve it like we usually do, we just bring it down.
Yes, and tell me though what you mean by we don't solve it like we usually do.
Like,
We don't divide it out because it doesn't go in evenly. Okay, that's what. But if it had been like 2/4, we would have reduced to 1/2. Okay? We do reduce. We just can't reduce these. Okay? All right, let's look at, well, I need to say something before you look at 12. Okay. One more fact that I need to give you that relates to slope. Slope of parallel and perpendicular lines. All right, let's talk about parallel. Parallel lines. Think about parallel lines. Let me draw a little picture. Let's suppose I have this line and I have this line. What do you think might be true about lines that are parallel? What might be true about their slopes? They are equal. If this is line 1 and this is line 2, and everything about them I call 1s and 2s, then slope number 1 equals slope number 2. The slopes are equal when the lines are parallel. They have the same rise over run, so their slopes are the same. Now, perpendicular. Perpendicular means to intersect, forming right angles. And let's suppose I have this one and this one. And they do intersect to make right angles. Do you agree that if you have perpendicular lines that you're always going to have one that's rising and one that's falling? So one's going to be positive and one's going to be negative. There's something else that you can't just tell by looking, but their slopes are going to be reciprocals of each other. If one of them has a slope of 2/3, the other one will have negative 3/2. So they are opposite and reciprocals. So here's what they say. M1 is opposite. Whoops, I hit that button. Opposite, so you'll see a negative sign, reciprocal of M2. But I like to just write those words down. Opposite, opposite sign, reciprocals. Example, 2/3 and negative 3/2. Okay, we've got a couple of questions to answer that are related to parallel and perpendicular. Look at number 12. It says, determine whether the pair of lines is parallel, perpendicular, or neither. Parallel, perpendicular, neither. Okay, here are the lines. We have x minus 3y is equal to negative 4, and we have y is equal to 6x minus 4. In order to determine whether lines are going to be parallel or perpendicular, or ultimately to conclude maybe they're neither one, we need to know their slopes. We need to know the slopes to determine whether the lines are parallel or perpendicular, or neither one. All right, if I want the slope, what form does the equation have to be in? Y's got to stand by itself. So for this first one, I'm going to subtract x, and I have negative 3y is equal to a negative x minus a 4. Divide by negative 3, all parts, and y is equal to, what am I going to write as the coefficient? What am I going to write as that fractional coefficient of x? There's a 1 there. So it's negative 1 over negative 3. What is negative 1 over negative 3? Positive 1/3. X. Negative 4 over negative 3? Positive 4/3. Now, why did I do that? Why did I solve it for y? Right, and what do I need from this equation? The slope. The slope is 1/3. And I didn't know that when I looked at it in this form, but I do know it now. Second line. How much work do I have to do?
None.
None, because it already says y equals. So I already know that the slope is 6. So compare those. Here's your thought. You have got M1 is 1/3. You have got M2 is 6. Are those two lines parallel?
No.
No, why not?
They don't hit equal.
They're not the same number. They're not equal. We said up here that two lines are parallel, then their slopes will be the same. And we just figured out that these slopes are 1/3 and positive 6. Okay, so not parallel. All right, perpendicular. Are these two lines perpendicular? Well, are the two slopes opposite reciprocals? No. They're both positive numbers, and they're not reciprocals, so no. When you mark off parallel and perpendicular, what's left?
Neither.
Neither. There was a lot of work involved in that to come up with the conclusion there. It is neither. It wanted to know if the two lines are parallel, perpendicular, or neither. In order to determine if lines are parallel or perpendicular, I have to know their slopes. To find their slopes, I've got to get the equations in the form y equals. The y equals is one of your very best friends. All right, let's look at, what number are we on? 13. Number 13 says, here's a pair of lines. I have 7x is equal to 4y plus 5, and the other line is negative 35x plus 20y is equal to 5, and it wants to know if they are parallel, perpendicular, or neither. Parallel, perpendicular, or neither. Parallel, perpendicular, or neither. Oops. Well, where do I start? What do I have to know to make those decisions? I've got to get them in the form y equals, because that way I can see the slope. It'll be staring me in the face. So I need y by itself. I'm used to having it on the left, but it's really no big deal if it's on the right. All right, if I want it by itself, do you agree I need to subtract 5? So I have 7x minus 5 is equal to 4y. And if you don't like that, then I can just turn it around. 4y is equal to 7x minus 5, and you probably all like that a little bit better. What's the last step I have to solve for y? Divide by 4. Y is equal to 7/4 x minus 5/4. Now we went to all the trouble to get y by itself. What is the slope of the line? 7/4. There's your slope. If you just get it in the form y equals, you've got the slope. Second equation, because this is a comparison problem. I want to add 35x to both sides. I get 20y is equal to 35x plus 5. Divide by 20. Divide by 20. Divide by 20. Y is equal to. The coefficient of x is 35 over 20. Can that be reduced? 5 goes into 35 7 times. 5 goes into 20 4 times. So that's 7/4 x plus, reduce again, 5 goes in there once, goes in the bottom 4 times. There's my slope value. The first one I'm calling M1, and the second one I'm calling M2, although that doesn't matter at all. But if M1 equals 7 over 4 and M2 equals 7 over 4, they are parallel. And you don't You don't have to work anymore once you've come up with a conclusion. If they're not parallel, then you check to see if they're perpendicular. And if they're not parallel or perpendicular, they are neither. Okay? All right, let's do one last one of these, and then I'm hoping that we'll have a little time for graphing at the end. All right, determine whether the lines are parallel, perpendicular, or neither. I have 6 plus 8x is equal to 7y, and I have 7x plus 8y is 6. Parallel, perpendicular, or neither? All right, what am I going to have to do to this first one? I want what letter by itself? Y. And if you want to, because we're so conditioned to have our y on the left, you can turn the whole thing around, and I'm going to rewrite it like that. 7y is equal to 8x plus 6. So I've used several properties to get to do that. Then I'm going to divide by 7, and y is equal to 8/7 x plus 6/7. What's the slope of this line? 8/7. The second line, I'm going to subtract 7x. So 8y is equal to negative 7x plus 6. I'm going to divide by 8. And I get y is equal to and I shouldn't have circled it up there. Oh well. Y is equal to negative 7/8 x plus, I can reduce this. 2 goes into 6 3 times. 2 goes into 8 4 times. So here's where I want to circle it. Here's M1. Here's M2. Okay, if M1 equals 8/7 and M2 equals negative 7/8, are they parallel? No, because they are not the same. Are they perpendicular? Whoops, that's bad. Okay. The answer is yes. They are perpendicular because they are opposites and they are reciprocals. Opposite reciprocals. And that concludes section 3.4 on slope. Slope from a graph where you do the rise over the run. Slope from points where you use the formula. Slope from an equation where you use y equals mx plus b. And then parallel and perpendicular.